My name is Charlie Vazac, and this is Nick Jansma, and today we're going to be talking to you about third parties and the havoc that they have the potential to wreak in your application or your website. But first, a little bit about us. We both work on web performance at Akamai. We're both spec editors as part of the W3C Web Performance Working Group, and we've both shipped web performance features to browsers. In addition, we're both contributors to an open source project called Boomerang. Boomerang is the JavaScript agent that runs in the browser that collects the performance telemetry that we beacon back to our servers to supply our run product with its data. And what that means is we too are third party. We've had successes and failures along the way. We've broken websites in the past, and we've had other third parties break us. And this is why we care so passionately about the third party ecosystem. Because we all share the same context in the page, we owe it not only to the host page, but to all the other third parties that might be present to all play nicely together.
Hello, everyone. So why are we here today? Honestly, we're here to scare you straight about third parties. So we all know that third parties are an essential component of building our apps today, right? Third-party services and libraries give us amazing tools to be able to build our apps without having to create all the different components that you would want, like analytics service or a templating engine or a SPA framework. These third-party services and libraries add value to our sites, but do we really understand the cost? How can we quantify what the cost is of these third parties when we're adding them to our page? Today we're going to cover all the different ways that a third party can affect your site, from the performance impacts of loading a third party just with that one line of JavaScript. We'll cover how compatibility and security are affected, and we'll dive into all these ways that a third party will be affecting your web page. For each of these topics, we're going to give you a couple different tools to understand what's going on. We're going to describe how you can evaluate a third party before you include it in your site. Once it's on your site, we're going to give you tools and techniques to monitor it to make sure it's behaving properly. And then we're finally going to let you know about how you can protect yourself against either nefarious scripts or unintentionally dumb third parties. So when we say third party, what are we really talking about here? At the end of the day, it's really code that you didn't write. These could be libraries that you include on your site, widgets, social widgets, analytics tools, fonts, CSS, all this kind of stuff. Any non-core business logic. Now, you might be including these third parties as part of your application's JavaScript bundle, or a third-party service might say you should be loading this third party from a script tag that you insert into your site. Or marketing's favorite way of getting a third party onto your site via Tag Manager. At the end of the day, each of these methods loads code that you didn't write into your app. First of all, did you guys realize we're on season 32 of The Real World? It's just kind of crazy. So today, this talk is the true story of 14 strangers, sorry, not strangers. Today is a true story of 14 third-party scripts picked to live in your website and to see what happens when they stop being polite and start getting real. So let's pretend you're building a new website, right? You probably depend on a lot of third parties to build it really quickly. You're going to start out with your SPA framework, something like Angular or React. You're going to add an analytics service to make sure that you can monitor all the visitors that are coming to your site. You might want some real user monitoring to see how the performance is behaving. And you definitely want to make money, so you're going to add ads, right? Marketing wants you to add some sort of remarketing script. You don't really know what it does. Next, you're going to be adding some script that no one really remembers why it's there, but it's just there. You want to make your site, or you're going to need some polyfills probably to make sure your site works with older browsers. You want to make your site interactive, so you add a comment section. You add a chat bot to be able to interact with your visitors as well. Just for fun, you're going to add the Konami code as a little Easter egg. Something that, there's going to be something that Bob added, but Bob's not here anymore. He hasn't been at the company for a year or two. You don't really know why it's there anymore, but you don't want to take it out in case you break the site. You want to make more money, so you add more ads. And then finally, you're going to add error tracking just to make sure your site's behaving possibly good in the real world. What could possibly go wrong? Let me tell you. The polyfill library that you included, well, while it's good intentioned, it actually broke a browser API that your RUM library depends on. Oh, also, that same polyfill library broke your error tracking. And because it broke your error tracking, you don't know that it broke your error tracking, so it's just broken. In the meantime, your SPA framework has a low severity security vulnerability that you should probably patch, and hopefully it's not going to be too bad. But that thing that Bob added, you don't really know why it's there. It actually has a high security vulnerability. You don't know if you can remove it, if you should upgrade it, what's going to happen if you remove Bob's script. While you weren't looking at it, the remarketing company sold to another shady company that's now stealing your users' passwords. Those ad services, well, they're making your site slow down like 1990s AOL. And that Konami code script, it's actually mining Bitcoin while you're not looking. So all this is to say that there are hidden costs to everything that we do, right? All these scripts that we're adding to our site, they have a cost associated with them. And it's really important for us to be able to quantify the cost of these things that we're adding to our site. It's not just that one line of code. We need to be able to understand all the side effects of these things that we're adding because they are adding value as well. So let's start with performance. So let's say you're this guy on the left. It's a Friday afternoon. Your boss man comes by and says, hey, we need to add this script that marketing wants to add. Please add it over the weekend. We need it by Monday. And you're like, oh man, well, that shouldn't be too bad to do. You go to the developer documentation for the website. It's just one line of code. They say you just got to drop this on your site and you're all set. You're like, whew, that should be easy to do. No problem at all here. What could possibly go wrong? Unfortunately, a lot can go wrong. That one little line can cause your page to stop loading. It can slow down your other components. It'll create incompatibilities with other libraries possibly. It can change from underneath you if you're loading it from another service. And at the end of the day, it actually has total control of your web page. And you say, but Nick, the script tag has an async attribute. That means it's fast, right? The async attribute is great. What it actually instructs the browser to do is that it can continue parsing the HTML while it's loading the script in the background. But there's also an important distinction here. Async does not necessarily mean that your page is going to load fast. The browser will wait to fire the onload event until all asynchronous scripts are loaded as well. So that means the loading indicator that you see when the page is loading and the little waiting for host in the status bar, they're still going to happen for an async script that is loading slow. So if you have just one async script that's taking 30 seconds to load, you're still going to get a loading indicator. Your visitors are going to wonder what the heck's going on, why is this page slow, and they may not even be clicking until all of these third-party async scripts are loaded. So in other words, async does not prevent against single points of failure. So what are we to do? Management is telling us to add this tag to our site. Theoretically, it has value. And while it does have this value, how do we evaluate its cost? How can we make sure that the value exceeds its cost? Let's start with one really simple way of evaluating a new library. Let's look at how big it is. What is its byte size? In this case, we're going to be looking at modernizer.js. Here's a very simple size of it, both uncompressed and gzipped if you're going to be sending it compressed over the wire. It's only 92 kilobytes regularly, 32 kilobytes gzipped. It's small, right? Cheap? I don't know. Seems pretty reasonable to add to your site. What does that 32 kilobytes mean in the overall context of your page? How does that library contribute to the overall page weight? So page weight is the sum total of all the content that you're loading on your site, all the bytes for all the resources, all the images, all the HTML, all the JavaScript. And page weight is important because it has a direct correlation to how quickly your site loads. The more bytes, the longer it's going to take to load. So if you increase page weight, if you're adding libraries, you're potentially increasing the load time. So every third-party library you add, you have to weigh it against your overall performance budget. You got to make sure it's worth the cost. But at the end of the day, that's just one way to judge a third-party library, how big it is, how many bytes there are. We got to step back a second. We really have to consider all the different ways that a library is going to be interacting with your app. We're first going to talk about how you load a third-party script onto your page, whether it's a loader snippet or in your applications bundle or a tag manager. We're going to talk about the download costs a bit more. The browser has to parse and compile all the JavaScript that it loads, which is very important with relation to the size of it, how many bytes there are. The script has to run, it has to initialize itself, register its APIs. And finally, the script is there for a reason. It may be because it's exposing the APIs you want to call, it may be responding to user input, or doing things like monitoring your performance or analytics. So the reason we have to discuss all these phases for all these different ways that a third-party library can interact with your app is because for the majority, they're actually all done on the browser's main thread. And so we're going to go into a little bit of details about what the browser's main thread is and why it matters for your site. So what is the main thread? In programming terms, it's where all the main work is done. So this is where parsing HTML happens. This is where executing JavaScript happens, doing layout. But actually, most importantly, in my opinion, it's actually where the browser responds to user input. So if the user is clicking or scrolling, that has to happen on the main thread. Each of these blocks of work are called tasks. When the browser is parsing the HTML or executing JavaScript, those are tasks. And if the user is clicking or interacting with the page while one of these tasks is running, like if JavaScript is running for 200 milliseconds, 300 milliseconds, the browser cannot respond to that input. So if you try to scroll when JavaScript's running, you're not going to get a silky smooth experience. So it's really important for third parties to try to minimize the amount of work that they're doing on the main thread, because these can all affect the user interactions. Here's a really kind of basic diagram of what I'm describing. At the top is the networking activity that's happening during a page load. The network is busy sometimes, sometimes not. And below is the main thread of the browser. So this is where all the work is happening, where it's parsing the HTML, executing JavaScript. If the user is to click at any point in the timeline where the browser is not busy, or even when there's a small task, a short task running, like a task that's only taking 2 or 3 or 5 milliseconds, they're going to get a good experience. If they scroll at that point, they're going to see 60 FPS because the browser's not doing a lot of work. But if they happen to click while a long task is running, something that's taken 50 milliseconds, 100 milliseconds or more, the browser's not going to be able to respond to that until the task is completely done. And so all of these points on the main thread are where your third-party libraries can have an interaction, and they can directly affect your user experience. Users that are clicking and not getting responsiveness to their input, they're going to get confused, they're going to get annoyed, they're going to think your app is slow. And this is especially prevalent on mobile devices and slower connections. So let's first talk about how the script gets on your page. You might be including the script in your application's JavaScript bundle if you're using something like Bower or Webpack. You might be including it via script tag. You might even have a loader snippet that the third-party service gives you to load it. Most of these do have a cost. They can be pretty small. If you are just including a script tag with an external source, there's actually not a lot of overhead in that. But if you're doing something like a snippet that you have to drop in your page, there is a non-zero cost to including that. Most snippets are 2 to 10 milliseconds on a desktop. On slower browsers on mobile devices, those can be anywhere 20, 30 milliseconds. And there's different advantages and disadvantages to how you're actually loading third-party libraries and scripts. We start out with the most obvious way is just including the library in your application bundle. Again, this is if you're using something like Bower or Webpack. The good thing is here is you get to control the version. You get to control exactly the code that's getting into your website. You control the order when it actually loads. It's going to load before the things after it within your bundle. The potential downside is it's going to delay anything happening after it, any JavaScript code that needs to load after it. External script tags are another way, and many third-party services want you to load their code from an third-party source. For example, this is how we do it with Impulse's Boomerang. The good thing is you get some parallelization here, especially if it's being loaded from a different domain, so the browser can fetch many things at once. But there's some cost to it. It takes some time to connect to that other domain. You don't control the version. If you are loading JavaScript from another URL, you are no longer in control of the code that's running on your site. Some services and third-party libraries will give guarantees about when they won't change the code, but at the end of the day, you are no longer in control of it. And you don't control when it's loaded, so you can definitely create single points of failure. And finally, everybody's favorite way of loading third-party libraries these days is via Tag Manager. Again, this gives you some parallelization. The downsides are it is a third party. You are adding an entirely additional round trip to get to the tag manager in the first place before the tag manager is able to fetch the additional resources. And as somebody once said, it's a great way for marketing or other people to get scripts in your website without you doing a code review. So now that the script now that you're telling the browser to fetch the script, the browser is going to go fetch it over the network. As we discussed before, each byte contributes to the overall page weight on your page and can affect the performance of how quickly your page loads. You really want to make sure that external scripts and external libraries are loaded from a CDN to make sure that there's good performance and reliability with loading it. And it may not be clear until you actually put it on your site what that script is also going to load. A lot of scripts and libraries have other third-party dependencies, like they're loading HTML or more JavaScript or an iframe, especially ads, if you think about it. Ads are going to be loading potentially megs worth of data of images and videos. A great way to help visualize this when you're putting a script on your page is to use tools, something like Request Map from Simon Hearn. You can get that at webperf.tools. And it can help you visualize all the different dependencies that one third-party library is fetching, even when you're just dropping them that one line of JavaScript. If we look at some of the popular JavaScript libraries out there, we can also see the difference in size and the complexity of them. So if you compare something like underscore.js, which is about 7 kilobytes, to D3, which is 70, that's almost 10x difference. If possible, you want to try to find libraries that are under 14 kilobytes. That gives you some nice networking properties where you can actually load the third-party script with one round trip. Anything more than 14 kilobytes will require more than one round trip to the server. And the size of those libraries has a direct effect on how long it takes the browser to parse and compile them. So as soon as the JavaScript source has been downloaded, the browser parses it, it compiles it, it gets it ready to run. The size of the library has a direct correlation on how long this takes. Less bytes equals to less compile time. As you see here, many of the libraries can compile, at least on a desktop CPU, in 5 to 20 milliseconds, but that gets increased, obviously, when you're looking at more of a mobile device. You might have some of the large libraries, like Angular, actually take 50 milliseconds to just parse and compile. And anytime the browser is parsing or compiling, it cannot respond to user input. So after the script has been parsed, the browser is going to execute the code, right? That's what it's there for. It's going to execute the initial code. Some libraries are doing things like registering their APIs. Other libraries are playing with the DOM. They're adding social widgets, or adding different HTML to your DOM. If possible, third-party libraries should try to minimize the work that they do upon initialization as much as possible, or they should break up their work so they're not doing just these big, meaty tasks where if the user is trying to interact, that they're going to get a bad experience because the browser can't do anything while they're executing. And then finally, every library is there for a reason, right? Libraries may be doing work to provide an API for you, or they may be responding to user input. They may be a charting system, or maybe they're collecting performance data and sending data out at the onload event. All of this activity happens on the main thread. All of it should be as minimal as possible, because all of that stuff can block user input. So that's kind of the life cycle of a third-party script. You tell the browser to get it, the browser gets it, the browser parses it, executes it, and then it runs. We think it's really important to be able to quantify this for every third-party script out there. We've actually done an in-depth performance audit of the Boomerang library that Charlie and I and others work on. And we published the results at the URL on top. We think it's really important to be open and honest about our overhead. We can't do anything on the page without actually doing some work. And we hope that the value that we provide to our open source customers or our customers through MPulse exceeds the minimal cost that we're showing. It was also really great because when we were doing this performance audit, we found a lot of things that made us question what we're doing, or we found different issues, different ways to optimize it that we want to do in the future. And so we have a log in GitHub issues of all the different ways that we want to improve Boomerang over time that came from this performance audit. We'd really love to see more third-party services publish something like this. We think it's really good for the community to be open and honest about it, and to give somebody that's looking into your library a way to evaluate it before they actually put it into their site. So now that we've discussed all the different ways a third party can affect your performance, what do we actually do to evaluate a third party script before you include it? How can you make sure it's good before you include it? A great way of doing this is to do some sort of A/B testing with the script on the page and off the page. You can use something like Chrome Lighthouse or Web Page Test to do this. You can use other tools like we mentioned before, like Request Map, to help understand all the different components that are fetched from the page. And I'll be going over this a little bit more shortly, but today we're actually going to release a new free tool that you can use called Third Party I/O, which performs audits on third parties and gives you things that you should pay attention to. So we talked about all of the different work on the main thread that a third-party library might be costing you, but there's a lot of other best practices as well. For example, if you're loading a third party from a CDN, from an external script tag, you should make sure that it is a CDN, that it has caching headers and timing allow origin so you can measure it. You should make sure that it's minified, compressed, all these different things. There's also some, every library that loads should try to minimize the work that it does. Minimal JavaScript code, minimal work, only set cookies if you need to. Don't change the DOM a lot, don't add a lot of event hooks. And there's some big no-nos too, like a third-party library should not be putting in alerts for the customer. It should not be doing console logging, because that can get in the way of the app's actual logging. It should not be doing JavaScript errors. And a lot of this stuff are things that Charlie's going to be going over in a little more detail in a bit. But it's kind of hard to really evaluate a third party for everything that it's doing here unless you're really performing a really in-depth audit. And that's just not practical for every third party out there. So as I mentioned, Third-Party IO is a new free website that you can go to. It's basically a Y-slow for third parties. You can paste in a JavaScript URL or look at the other third parties that we've already measured. And it's going to go and perform some automated performance audits about the network. It's going to launch a headless browser and load that third party in it. And it's going to measure how much CPU time it takes, etc. So here's an example of how Akamai Impulse performs, the work that it's doing on the main thread, how many requests it fetches, and it'll give you in-depth details about all these different checks that we're doing, why you should care, how you can fix it if it is your own third party, etc. So next, after you've included the third party on your website, you think it's a good one, you're going to include it, you should still monitor it. You should still make sure it's doing all the things that you expect and that it's not killing your user experience. So you can use things like real user monitoring to do this, or you can use other synthetic tools like SpeedCurve or Calibre. They give you really good insights into third parties. And finally, there's some browser APIs that you can do it yourself. Something called the Long Tasks API is currently in Chrome, and it can help you monitor all of the bad potential long tasks that are happening in your page, and you can measure them over time and get attribution onto who's causing them. So finally, you should also protect yourself. You should make sure that bad third parties aren't going to negatively affect yourself. You can use things like resource hints to trigger downloads quicker in the page than when you put the script tag. You should really consider how you're loading the script, as we talked about the application bundle or using a script tag or using a tag manager. You should lazy load third parties if possible, or consider maybe it doesn't need to be on every single page on the site. Only load them when you need. And things like service workers can help protect you against single point of failures by you can stop a third party if it's taking too long to load. So, and finally, we think that every third party that you include on your site, you should have an internal champion, somebody that knows about it, somebody that understands it, and somebody that you can go to for questions. And Charlie's going to talk about that a little bit more.
We think internal champion is a good idea because it forces one person to take responsibility for that script. There'll be one single source of truth to answer questions like, why is this script on the page? What value is it adding? Is anybody still using the data that it's providing to us? How long should it be there? What pages should be included? So now marketing is back, and they want you to add 2 more third-party analytic scripts. But this should be done with caution. Writing code as a third party is extremely difficult because you have no idea what else is going to be in the page, both before and after you get there. Third parties can affect each other and the host page in some really subtle and hard to track down ways. And it's usually only the happy path that's tested. But particular attention needs to be paid at the 2 major friction points, polyfills and built-in patches. So concerns about third parties in your page come down to the who, what, and when. Who else is in the page? Are certain scripts only included and thus only tested in production? Are any of your third parties pulling in other dependencies? And what code are they executing? What browser APIs are they patching? Are they bringing in any polyfills? Do you and the third party share the same browser support requirements? And have you tested them on older browsers? And then when are these scripts actually loaded? Are they sampled? Will a bug only be produced some mysteriously low percentage of the time? And loading order is not always guaranteed. Scripts could either be lazy loaded in or included async. Maybe a bug will only exist if they're loaded in certain orders. Lastly, when do they ship new releases? Are upgrades opt-in? So polyfills are a typical friction point that can cause problems within your page. When you or someone else drops a polyfill into the page, you are basically tricking all of the other scripts that a particular API natively exists in the browser. Developers would typically only existence check APIs. No one really checks to see if the function is a built-in or a polyfill. And that's where we get into trouble. So let's take a look at an example of how incorrect, or rather incomplete polyfills can cause script errors in your page. Several years back, Boomerang coexisted with a third-party lazy loading library. The library polyfills the request animation frame method, falling back to the older set timeout. Here, the developer gates her usage of the API with a simple existence check, but she doesn't existence check cancel animation frame, because why would a browser implement one without the other, right? Well, in this case, the third party broke the promise to the host page that certain APIs existed. And as a result, there were dozens of script errors per second, which was enough to overwhelm IE9 in this case. Users with older browsers would consider your site completely unusable, and they're going to notice. But what is more subtle is data corruption. There's a third-party library that touts itself as an accelerated JavaScript animation framework, whose existence we only learned about the hard way. The library is pretty popular too, with over 250,000 downloads from NPM per week. As you can see here, they polyfill performance.now, falling back to the date API for older browsers, which works, but the problem was they were incorrectly using the DOM complete as the epic, where they really should have been using the navigation start. So because of these timestamps, and they could be literally seconds apart from each other, the existence of the library corrupted all of our RUM data for older browsers, leaving our data scientists scratching their heads. We found the problem, they merged in our PR, and life goes on. But you really have to you have to be careful when pulling in polyfills, or if a third party pulls in a polyfill into your page without you realizing. Because there might be other people relying on that, you'd better get it right. We often see pages that polyfill built-ins that already exist in the page, which is crazy. And I promise you that your JavaScript implementation is not going to be as compliant or as performant as the C++ built-in.
Yeah, and bringing it back to performance like we were talking about earlier, all these polyfills have a cost. They have a page weight, right? You should not bring in polyfills unless they're needed. If you're shipping down all your polyfills to all your modern Chrome browsers, you're wasting bytes. So it's a lot better to do feature detection and load these polyfills as needed, or even doing some user agent sniffing potentially, or other methods of loading these polyfills only when needed.
So this is the other major friction point that is often rife with compatibility issues. Monkey patching, swizzling, hooking, spying, whatever you want to call it, there's a lot that can go wrong here. And if it's not done perfectly, when two unrelated scripts attempt to patch the same method, the host page can be left in a broken state. This is an example of how patched built-ins can break the host page window listeners. This is the code of a popular JavaScript library that simulates the history API for older browsers. Because those older browsers do not natively dispatch the hash change and pop state events, the library patches window.addEventListener and collects those callbacks registered for those events so that it can later dispatch them at the right time. First, they feature detect, falling back to the legacy attach event method. Then they assign a reference to the built-in function to a local variable. But then when they delegate to that built-in function, because they just invoke it instead of using .call or .apply, they essentially unbind addEventListener from the top window, which might not matter to some, but Boomerang runs inside of an anonymous iframe. We instrument the top level of addEventListener, but because it's unbound by the time we get to it, we've lost our outer context. This means that if a host page attempts to add a listener to its own window, it's really adding a listener to our anonymous iframe. So if it subscribes to load or message events, they simply are not going to fire when they're expected. This shows that sometimes it's the subtle interactions between two unrelated third parties that can break the host page. And it's this kind of bug that is very difficult to catch before you get to production because of the number of factors that are required to reproduce it. What's even more scary is that patch built-ins, even if they're done correctly, can stop your code from executing. The coding order and the prototype chain make this a really hard problem to solve. So Angular now uses something called zones to handle asynchronous callback execution context. To make XHR responses zone aware, they patch addEventListener various levels of the prototype chain. Take a look at how a common patching pattern works. When you patch a store a reference to what the native built-in was at that moment. After code gets a chance to execute, you then delegate back up to that method. Well, so Boomerang also needs to listen to XHR response a bit later and patch event-target.addEventListener, which is higher up the prototype chain than where Angular patched. So now, when you call addEventListener on an instance of an XHR, Angular will accept that call first because he's lower in the chain. He will then delegate up to what he saw XHR addEventListener to be, which is the native event target addEventListener, the top of the chain. Boomerang's interloping code will no longer execute because Boomerang's patch was never delegated to. So if a prototype method like addEventListener is patched, by the time your script executes, you no longer have the ability to patch at a higher level. Your code just won't execute. So these are the things that we consider to be best practices when it comes to protecting yourself against compatibility issues with third parties. You should really prefer third parties that support self-hosting. This will allow you to control the release cycle. You can bring in the updates when your shipping schedule allows. And you can also statically analyze the code as part of your build pipeline. You should understand and identify and understand the built-ins that they've patched. I wrote a bookmarklet that's in my GitHub that you could run against a page and it'll help you identify what built-ins have been patched. You take a look under the hood, see what they've patched and why. Check to see if they've done it right. And note that you should also be concerned about APIs that you might not be yet using because you might start using them in the future. As for polyfills, those need to be manually audited. Ensure that they're spec compliant. Also, you should never polyfill a built-in that already exists in the page, so don't let your third parties do it either. Lastly, don't let them rot. If your app supports 2 versions of every major browser, that means that you need to evaluate these polyfill decisions every time somebody ships a new browser. You should hold third parties accountable for script errors. Assuming that you're collecting script errors, air tracking in the browser has come a long way in terms of attribution. File bugs, but also submit PRs to open source projects. Let the community benefit from your work. If you bundle a third-party code yourself and you use ESLint, they have a rule that can help notify you when they've detected that a native has been. You can find out about that at build time. But now your boss man is back. And he's curious about why his computer fan goes on. It's your app. So when it comes to the security of the users of your app or site, every third party that you bring in is a security risk. Your site is only as strong as its weakest link. Even just that one line of code that marketing asks you to add can open yourself up to vulnerabilities. Because ad networks are heavy users of document.write to write their own code and other scripts, they are ripe for cross-site scripting attacks. And as if needed another reason to stay away from document.write, here is one. This is an example of a cross-site scripting attack where the refer is reflected back into the JavaScript code. So now they add revenue up your site to attack malicious code executed, fully privileged. So why is my running? I'm sure this happened to a lot of people out here. I feel like more and more often I have to kill some of my browser tabs because they just become unresponsive for whatever reason.
Do we need to do something different with the mic? Okay.
So this happened to a security researcher in the UK a couple months ago. Someone on Twitter tipped him off that a government website that actually advocates for data privacy, interestingly enough, might have a cryptominer installed in it. So he did a little digging and he found that more and more sites were compromised. Well, they all happen to be using the same third-party accessibility tool, but unfortunately that tool had been compromised. This is the snippet of code that was being injected alongside the code for the accessibility tool. And in case you don't read hexadecimal, here's the ASCII representation. As you can see, it makes a request to coinhive.com, a company who has a service that allows you to mine from Monero in JavaScript. Their tagline is, monetize your business with your user CPU power. This is a practice that I've seen online referred to as a victimless crime, but I personally find it distasteful, and I prefer that it not happen on my machine. There have been very similar breaches on other web pages, showtime.com and even DoubleClick. So a content security policy would have helped here. CSPs basically allow you to whitelist the domains that you trust, the domains that you want to allow to run script. It's not easy to use, and it's harder to get perfectly right, but there are a lot of online tools that help you to get started. Additionally, it's shipped with a report-only mechanism, so you can try out your policies without switching them on and potentially breaking things. In short, everybody should be using a CSP. The other browser API that would have helped here is Subresource Integrity. SRI essentially uses fingerprinting to stop what equates to vandalized JavaScript from being executed in your web page. You use SRI to ensure that the downloaded content for linked scripts match exactly what you're expecting. Otherwise, it simply won't execute. So it would have caught this problem with the accessibility tool. It would have thrown a network error. Browser support is getting there, although it's not yet in iOS Safari, and it will never land in IE. But in addition, CSP and SRI can work together. There's a CSP directive that will force you to require an SRI on all scripts. So hopefully I've convinced you that you should be using a CSP on your base page and you should be pulling in third-party resources with SRIs applied. But what about the code that passes those two safeguards, the code that you have essentially fully blessed? How can you keep an eye on third-party code after it's landed in your page? Well, earlier this year, researchers discovered that a very popular analytics provider was leaking out passwords and credit card numbers through their session replay agent. And this company tries very hard to care about security. They don't read values from hidden or password inputs, and they check the names and IDs looking for potentially sensitive words, including translations in different languages. But what they didn't count on was the presence of another third party and the way that they could affect the DOM. React made a change earlier last year that made this leak possible. React was copying the sensitive value attribute from password inputs and sticking it onto what we used to call expandos. The analytics provider had really no reason to suspect there were any sensitive data in those attributes, so it was beaconing them back. Now, to be clear, neither React nor this analytics script was doing anything explicitly nefarious. It was only when they were working in tandem that it allowed this sensitive data to leak. It's these extremely subtle interactions between code from different entities that I lose sleep over. So you can say that you're just going to read the code of every third library that you bring in, but come on, surely nobody can read this. This is generated from a brilliant site that can rewrite any JavaScript with just 6 characters. And this is obviously extreme, but there are more subtle ways that people attempt to cover their tracks. In addition to obfuscation, bad or otherwise sneaky actors are also heavy users of eval and document.write to introduce new execution contexts, which makes it really hard to step through. Static vulnerability checkers can help a bit, but the bad actor can just mask keywords. And on top of that, reading the source code might not even help. You can publish one version of the code on GitHub, but then ship another version to NPM. The only thing that cuts through all of this noise, the only thing that can't be tricked, is code-level instrumentation. Whether you write your code with evals or in hex or Unicode, or go all in on crazy and use only 6 characters, in the end, the code that executes is the code that executes. If I've patched the fetch API, this crazy obfuscated code won't be able to hide that call. My patch code will trap it. Here's a non-existent list of properties and methods that can be instrumented and or blocked by whitelist. And the existence of the usage of any of these APIs does not necessarily indicate that there's malicious activity, but that these are the things that I would want to know about if I owned a web page for a company that cared about its public perception. Third-party I/O is already tracking many of these APIs. So these are the things that we consider best practices when it comes to protecting yourself against security holes and privacy leaks opened up by the use of third parties. So we should really consider HTTPS links only to reduce the risk of in-transit modification. We can scan for our dependencies for vulnerabilities. Sneak has a very easy tool to integrate into your build pipeline. NPM just announced the Audit command, which will perform an instant security review of your entire dependency tree. Longtask is a performance API, but it would also help you to identify high CPU intensive scripts like crypto miners. If possible, you're going to want to sandbox your iframes. What that does is it prevents the code from inside of an iframe reaching up, reading your cookies, local storage, or attaching handlers. CSP and SRI are a must. Also, you can freeze sensitive APIs. I wrote a zero dependency package that's on my GitHub that will basically lock down any API that you don't want to be modified just by no-opping reassignment calls. And in the end, it's only code level detection that can report on these things. JS Scrambler has a solution that they call Website Integrity that they say protects against some of these APIs, and I'm sure there's other tools out there that do the same.
So let's say it's another Friday afternoon, boss man comes by and says, you know, one more thing, what are you gonna do? So I hope we've kind of given you a heads up on all the different costs that a third party can cost for your site. Everything from performance to compatibility, security, everything has a cost, and you really need to weigh that against the value of what it's providing. There's tools that you can use to evaluate third parties before you include them in your site. You should continue monitoring them even after they're there. And you can use things like SRI and CSP to protect yourself against nefarious scripts. In our slides, we have tweeted out the slide deck if you look at Nick J. We have links here. I won't go over all these. We also have some other references as well. So just want to say thank you for coming to see us. We'd love to get feedback in the O'Reilly app as well. We're running out of time, so we'll probably just take questions out in the hall afterward, but we really appreciate it. Thank you.